Good afternoon, everyone. Myself, Ravi Susant Chaudhury. I am currently working as Deputy General Manager in Power Grid Corporation of India. Currently, I am looking after digital transformation in transmission asset management for Power Grid. So, before I'll come to the very technical part where AI is being applied in Power Grid, I'll be just touching upon few, interest in very interesting facts of AI. So this is a newspaper cutting which was long back in 1950s. It was published in Telegraph, wherein someone imagined that after 60-70 years, what is going to happen. So if you don't have dreams, nothing will happen. So somebody thought that after 50, 60, 70 years, you'll be having a phone or you'll be having a system wherein you'll be able to not only talk to each other from a far distance, but you will also be able to see each other. That is what we call as video calling nowadays. So it's a very old cutting. So so there are some milestones. As far as the AI, because some of students are there. So some of the milestones are there. I think there was a Turing groundwork work in 1950s. It happened, and after that there was a establishment of AI Act in 1956, and from 1970s onwards up to 1990, somehow the concept of AI was not that much coined that it should have been, right? So there was a Turing test also during that time, wherein he wanted to establish whether it was really a machine can do human work or not, whether it can ever have human intelligence, a kind of human intelligence, not the total human intelligence, but part of human intelligence or not. So he had a Turing test wherein he had two people, and he just tested whether the person who he was talking to is not a machine, but he's a human. So that test was passed. Again in 1997, there was a major breakthrough in AI when this Gary Kasparov, who was unbeatable at that time, was beaten by IBM with the help of Deep Blue software. So that was the major breaking milestone, and it was that time this term of AI was again refreshed and coined again. So when we start our daily work, we have so many phones, we have so many mobile applications. Our first thing, we start with the face recognition. So this is the most beautiful application of AI. And I think sir was talking about the accuracy, and nowadays we are having, because there is so much data set available, the day in day out, the accuracy is improving, and so is the confidence level. Again, Ola, Google Maps in the morning, when I just boarded the flight, there was a message that there will be a air turbulence, and winds will be around 250 km per hour after 2 hours, before landing at Kolkata. So there are so many things which are being, and especially as far as the biggest thing is concerned, when your major stakes are there, that is war. So in case of war also, these are the convention. This is how the conventional wars are fought in 1950s and 60s, Second World War. And now you see in the latest, if you have just studied gone through the statements of the latest happenings in the war, whether it's Gaza, whether it's in India, Pakistan, there was so much AI used during those wars. Whether it is Iron Dome, while intercepting the missiles, it totally calculates the projectile motion of the coming missiles through the help of AI, and it only counters the missiles which are going to hit the key establishments. So it is not going to hit the missiles which are not causing any damage to the key establishment. So that is why it is very important that the world has totally changed. In the most important task also, we are using AI. And what is AI? I think it is more or less it is covered. So I'll not go in detail, but just to add that, this is the complete AI, and mostly the ML is something which is the mostly being used by us, and deep learning, which is the neural network learning. So these are the neural networks. So we call it as an input layer, we call it as a hidden layer, and we call it as an output layer. So lot of computation is being done at every neuron level. So that is why, and why I'm covering the neural networks, because this practical case has already been implemented by Power Grid, and it was awarded, it has received a global recognition in 2024, wherein we have a PG Amrit, where artificial intelligence is being implemented to detect the tower line defects. So that also I am having a video wherein I'll show you that how that complete concept works in reality. So why AI now? So we are talking about 1950s, we are talking about 1960s, we are talking 1970s, 1997. Key milestones were there, but it is very important that before we implement any technology, or before we have any new transformation, you need to have certain pillars which are built in. So currently the foundations are all ready. We have a lot of data sets available. Earlier we don't, we used to have, if I think, I don't know, the younger generation, they have seen those cameras wherein you can click only 36 photographs at max and the film is over. And 36, also the 36 photographs, you're not sure whether that will be clicked or not. So at max for the whole day you can click only 35 photographs, and to keep those photographs it was a challenge. We have to store these photographs. So now we have a lot of data storage, we have a lot of technology advancements. It is very important to understand that if you don't have technology, you cannot implement AI. A simple example is that you have a simple bulb which is, or Alexa, which is controlled by AI at a home. It is very important that you should have a technology wherein it is able to control its lumen. For example, if LDR is not available, then you will not be able to do anything with the AI. So it is very important that technology should be available so that AI can further master that. Then you have very, very fast computing, because we are talking about so much of data set, and every neuron, for a simple image evaluation, it does 10 raised to power 6, or I will say 10 raised to 8 computations at every neuron. So there is a huge computing involved in this case. Automation has been the major strength now, because it was, most of the automation has been done from 2000 to 2010. Now we have a connected world, so everything is connected. You can work from anywhere and you can use data from anywhere. So that is another aspect, that why we are using AI now. And you have data centers. We were talking about data centers, and data centers are going to be a major business opportunity for all the entrepreneurs in next 10 years. And as sir was talking, we are having a very important saying that AI is AI for power and power for AI. So I mean, we are using AI for our power systems and power transmission planning and asset management, but we need also to have a framework wherein we can provide a reliable and uninterrupted power for all these data centers and all these AI hubs. So this is going to be a major challenge which is going to be done in next 5 years. And let me just add on to that, that government is already working on a very, very fast track. We had several meetings at the transmission level for covering this aspect, and India will not be falling behind as far as this aspect is concerned. So this is Power Grid overview. I think we are the third largest transmission utility in the world. We are largest transmission utility in India. We have more than 1 lakh megawatt transmission capacity, interregional transmission capacity, and approximately 50% of the transmission power flows through our system. So Power Grid, you can simply imagine your veins and arteries. So basically heart is your generation. So whatever blood goes, it goes through your arteries and veins. So this is your complete transmission system. Just a simple analogy. So I mean, why it is needed? I mean, I've already covered that aspect, and I will not repeat it again. How it can be done, and another important aspect which is going to come in next 3 or 4 years, that is IoT sensors. You are going to have lot of IoT sensors in upcoming years, and lot of data. It will be creating a lot of data points, and those data points needs to be properly evaluated and analyzed, converted to information, knowledge, and wisdom for a decision support tool. So these are some of the things where we have already the foundation blocks are there, and where we are using it. So I mean, the ecosystem is very important, wherein in our organization, if you are not able to have a positive ecosystem for AI or digital transformation, you will not be able to implement any technology. So we are having a complete ERP system wherein we have more than 15 TB of data for our complete plant maintenance of assets, that is available in the historian. Then we have the OT data which is available in our historian. Then we have the complete, more than 300 employees have been trained in AI from IIT Bangalore. And we have different in-house applications. We have more than 400 graduate engineers trainees from the computer background which have joined in an electrical company. So this is a huge transformation. So we are looking for a world wherein, electrical, we're looking for an organization wherein electrical engineers have to work in collaboration with your IT engineers to make system more efficient and effective. So these are some of the applications you can go through. What exactly we are using in so many, small aspects. We are using AI, even our HR chatbot. Then we have even attendance systems in Power Grid. We don't do it through biometric machine. We have a mobile app. So today, if I have come at Kolkata, I have to just open my mobile app, that is PG Mass. In that mobile application, I have to just have my face recognition, and it will be punched that I am at Kolkata and I'm on tour. So we don't have any biometric machines now. So it is all done through AI. So that is also in-house application. So what has changed for last, except ERP, most of the in-house applications are now developed by Power Grid IT engineers. So PG Amrit, I've already told that it has fetched a global award, reliability centered maintenance, which calculates the real-time health of assets. How it calculates, I'll give a small example. Then we have satellite imaging, wherein we are having a collaboration with ISRO, wherein we are going to predict the upcoming cyclones, disaster management, the change in river courses, which are going to affect our transmission lines. In addition to that, we are also going to have the complete assessment of the forest fires, so how it can affect our transmission lines, the exact coordinates. And let me tell you, the complete 5 lakh assets of Power Grid are mapped, are geotagged. So everything, the groundwork is already done. So we are very soon in 2026 we are going to launch that satellite based decision making support tool. And we also have satellite based management tool in NER, because there have bamboo, there is a major issue for transmission line maintenance. Then we have set up a module for each and every equipment, wherein we have AR and VR technology for young engineers. Whenever the young engineers they join Power Grid, earlier it used to happen that whenever they will get any opportunity, a transformer is open or GIS is open, they will not be able to see any internal parts, and they will not be having the practical knowledge of operation and maintenance of the system. Now with the help of AR and VR technology, we have converted them in the 3D modules, and they can go to they can wear the AR VR glasses, and they can see the complete inside. For example, in a transformer, they can see the complete winding, the core, the PRD, whatever is there. They can simply imagine, and whenever they go to their field, they are more confident and they are better equipped. Digital twin of substations have been created, and in addition to that, we are going to implement asset performance manager, which is a real-time predictive tool, and this is going to first of its kind in India. So it is a 200 crore investment, wherein we are going to integrate the complete IT and OT data, which will be of the tune of around 30 TB, and that data is going to be in CDP, that is a common data platform, and from that it will be having a in-house analytics, and wherein it will be predicting the risk, health, and the future course of action for each and every asset. So I think this is the our PALMS, we call it as PALMS in Power Grid. It is Power Grid Asset Life Management System, wherein the asset health is calculated. For example, your body health is calculated with the help of for parameters like your blood pressure, your sugar, or whatever the key parameter, your ECG or heartbeat. So, or some servers talking about eye and all those parameters. So similarly for assets, we have mapped all the parameters, we have given them the weightage, and that weightage is calculated, and ultimately these parameters, they ultimately evaluate the health of an asset. So this has a inbuilt AI algorithm. For example, if BHEL, for example, if any make transformer has failed in that batch, so it automatically identifies the complete batch, and it makes that batch critical, so that you have to evaluate the complete health of that complete batch if your sister unit has failed abnormally. So that AI analytics are inbuilt. For example, in a circuit breaker, what we do is that, for example, a breaker at a Delhi, which is working in operating at an NCR region with a high load, the fault amperes are very high in those zones. So I-square are the electrical life of breaker is calculated by AI, and it predicts that how long that breaker will be able to survive in this kind of environment. So all those in-house analytics are built by, these are liability center maintenance. This is also AI tool, which is these all dots are the assets which are mapped in impact axis and the probability of failure axis. I don't have time, otherwise I would have explained the complete thing. In addition to that, these are very I mean, sir was talking about health, so I can completely relate with this power system. So this is basically a DCRM signature, dynamic contact resistance measurement. So this is a signature which is quite complex, and engineers used to take on an average more than 30 to 40 minutes to evaluate a single signature, because you have to see the what is the resistance during the arcing contact, and when the main contact is made, what is the what is the resistance, then what is the velocity and the travel and everything. And most of the time the accuracy was less than 50 to 60%. With the help of AI, now all the signatures, all the 9,000 signatures of the circuit breaker are being evaluated with the help of AI. We have fed all the data that what should be the value, what should be the steep, what should be the slope in each and every frequency. So everything is mapped, so it automatically evaluates the health of that particular parameter, and it incorporates in the health model. So a lot of time saving is there, and accuracy is very high. IoT sensors, we have thermal sensors. I mean, we used to have the normal cameras in the substation. Now we have converted some of the cameras to the thermal cameras. So what they do is that with the help of infrared technology, they assess in case of heavily loaded substations like in Delhi, what happens in the summers due to adverse climate conditions. There is a lot of heat which is dissipated, and normally there is a lot of failure of the equipment. So it automatically assesses the trends of I mean, increased thermal radiations, and it evaluates, and it gives you alarm that this portion has become critical in the substation, so you can have a preventive healthcare in this case. So this is a model of which was awarded. Earlier we used to go and we used to punch the data manually, and now we have an automatic system wherein this evaluation is done automatically. So automatically the picture goes in. We have trained this model with the CNN concept and neural network, and this basically has a capacity of trained with more than 4 lakh photographs, and this has a capacity of uploading evaluating 400 pictures in 1 minute. So it has a high volume, it is very fast, and its accuracy is now more than 80%. Earlier it was 60%, and manually is less than 50%. So its architecture is there. I don't have time to explain. We have a in-house robot for inspection for all the substation, which has been made in collaboration with IIT Kanpur. So it is already under the operation. We are adding certain more features in it. We have valve hole robot, which has been made for HVDC applications, and this has been made by Power Grid only. And this is because people were not able to go inside the valve hole. So all kind of inspection inside the valve hole is being done by. Then we have the digital twins. We are made for one substation. Now we are going for other substations as well. Then satellite image intelligence. We have a simple bird eye view, indicating all our KPIs in a single dashboard. So in the morning, top management gives a view, and all the KPIs are monitored in a single click, and it refreshes every hour. So it is integrating the IT and OT data via AR, via training. I've already explained, and AI, power for AI and AI for power. I mean, current power requirement is 1.0 gigawatt. We were very comfortable. We are expecting 8 gigawatt 2022. We are still comfortable. The demand will be around 50 terawatt hour by 2030. I mean, this will be huge, and this will be supplemented with lot of pump hydro systems, then battery storage systems, and the cooling solutions. There will be a lot of water requirement also. So that is also being planned. What are the advantages? I'll cover some of the advantages. It is very accurate, fast response. There is no bias. So human bias is very important if it is out of the system. Then data driven decision making. It is not drive, it is driven decision making. It is uniformity. It is saving a lot of human manpower. We have a lot of expenditure on human manpower. So we have to be, models are scalable. So no variant, multitasking and task multiplication, server telling. That is the key feature of AI. Then we have asset performance manager. It will be doing a lot of human intelligence work itself. So I mean that is going to the future of Power Grid. So thank you. With this, I am going to close. I have scarcity of time. This small video, if you can show. This is a small video of automatic defect analysis of transmission lines by using AI. So I think that will be beneficial for all of you.
It's one of the world's largest transmission networks, stretching across 1.8 lakh circuit kilometers with more than 2.9 lakh extra high voltage towers. Spanned through diverse, challenging terrains, this vast network energizes India's everyday life, bringing reliable power and sense of certainty to every corner of India. Maintaining such a vast, geographically scattered network is an immense challenge. Traditional patrolling depended on manual checks, thousands of photos reviewed by human eye, defects marked by hand, consuming over 900 man-hours daily. As assets grow and expectations rise, the grid demands speed, accuracy, and AI-driven intelligence. To address these challenges, Power Grid innovated PG Amrit, an in-house AI/ML platform that analyzes GPS-tagged inspection images to automatically detect tower defects with speed and accuracy. More importantly, PG Amrit strengthens preventive diagnostic by introducing objectivity, traceability, and system-driven oversight into inspection and maintenance processes, ensuring accountable and transparent material utilization. This enhances transparency, accountability, and control across the asset management domain. For simple, clearly visible defects, PG Amrit runs a quick scan by applying a generalized model once on the inspection image. Issues detected are marked with bounding boxes, enabling high-speed screening at scale across thousands of tower images. PG Amrit detects complex defects using a multi-stage AI process. First, the system isolates key tower components by extracting the target part through region-based segmentation, separating it from background elements. In the next stage, a component-specific AI model analyzes the extracted region to identify defect patterns such as missing parts, looseness, misalignment, or damage. PG Amrit enhances preventive diagnostics by ensuring traceable inspections and transparent material utilization.